Hello, I am Satu-Pia from LUT University, and this video highlights our results from NaStA project and a new published master's thesis written by Aleksi Surakka. NaStA project is coordinated by Geological Survey of Finland and funded by EU. The aim of the project is to improve the operational environment of the SMEs connected to stone restoration sector. Finnish natural rocks and namely rapakivi granite has been applied in construction since 18th century, but origin of the building stones is not always known. Databases on utilized stones and quarries were built as a joint activity in this project. LUT is one of the 6 partners. In NaStA we have 2 main activities. One deals with changing visual appearance of stone surfaces with chemical and thermal treatment. Our other activity aims in developing tools for defining chemical fingerprint of stones and rocks and defining similarity between quarries and construction stones. You can find a description of the mathematical procedures and case studies from the master's thesis of Aleksi. 4 rapakivi variates were applied in the thesis. Viborgite is the most common rapakivi in this area. 75% of the rapakivi granites in Viborg patholith are Viborgite. In addition to it, Pytterlith, dark rapakivi and dark green rapakivi were applied. Geological Survey of Finland measured rocks from several Finnish quarries and Finnish and Russian buildings with handheld instruments. Applicability of these datasets for defining similarities or even origin of building stones were evaluated with multivariate and machine learning tools.
Hello, my name is Aleksi Surakka and I will introduce the 2 cases that were the experimental part of my thesis. In the first case, chemical data obtained with portable XRF device was used to define the most similar quarry from southeast Finland compared to 2 building stones from St. Petersburg. All the quarries and building stones were Pytterlite variety of rapakivi granite. And the similarity detection method was based on principal component analysis and soft independent modeling of class analogy. The data obtained from the 3 queries was used to calibrate 3 separate principal component models. The building stone measurements were then projected to the quarry principal component models, and the method revealed that the building stones were most similar to Heponiemi quarry. The Simca-based approach was promising, but one has to pay special attention to data preprocessing to create representative data and to bring out important features from the chemical data. In the second case, spectral data was measured from 4 different rapakivi granite with portable FTIR device. The sample measurements were then used in a classification problem to see if the differences could be learned with the used methods. Every sample had surface variation, which resulted in different spectra for the same sample. At the same time, all 4 rapakivi granite samples had same minerals, which resulted in similar patterns between the samples. A reduced measurement rate was used for the calculations. The classification revealed that Simca for the FTIR data was challenging. This was due to overlapping data between the different samples. However, By tuning the Simca parameters, the results did have improvements and the majority of the samples were correctly classified. A convolutional neural network with metric learning also displayed promising results to correctly classify the samples. More information about the calculations and the results obtained is available in the published thesis.
Thank you, Aleksi. You have great results in your thesis, and anyone can download it from LUT publication database. There are some other publications also already written or under writing. The project will end in 2022. Anyone interested in is always welcome to contact us to gain more information. Thank you for your attention. I hope you got interested in this master's thesis and will download it from internet.